Welcome guys to another tutorial. In this case we're going to be learning how to make a really nice balloon simulation for any type of unveilings. You can unveil anything, covered in a cloth of course. So stay tuned and watch the full tutorial. Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop dev, compositing. We will have resources for every type of discipline. So, hop in and have fun. I also have a Patreon page where you can support me. I have every single file, I have polls, I have even some tools, guidance. So if you are interested, you may have a look. Thank you. So welcome guys to this new project. So let's begin to see what we are going to achieve. First off, we're going to achieve something like this. This is of course not the post process, so I wanted to show you how this is done. This is done by a single point, dragging some lines attached to the back of this shape. Of course, when we post process, this is going to look much better. So let's hop in and let's see what happens. To begin with, we have two things. We have a car, which is very big. This is how it looks. And it has some points. These points are due to the rigging, but we clean those points because we don't need it, and we transform it to a real scale. This is by 0.001. And one thing to notice is that it comes with some properties. In this case, I wanted the name because if you are going to bring this to Solaris, just make sure to have some way to select the materials easily. And it came with the show material. So what I did is to turn the base name as the show material. That way you will separate your objects in Solaris easier. So this is the object, and as far as I can tell, I do want to have a cloth on top of it. And this is my cloth. The cloth consists on this shape, which we can of course lower the resolution just for the sake of it. This is how it looks, even a little bit more, just so we can visualize this faster. And this is the patch. And we're going to have one singular point called end, which is this one, and this patch name with the very edge grouped. So what we are going to do before we connect these two guys is to work on our collider. So our collider is basically the car we already had, and I'm going to explain something. So what's the matter here? The matter is that if we explode the view here, we got a ton of very difficult shapes, which some of them are inverted, some of them just are overlapping. This is not good. This is not going to work, or it's going to be very slow because we have over 800,000 polygons. It's going to be slow. So the following solution is not the best solution, but it works. It really works. So what you get to do is to basically scatter some points on the surface. I decided to use this amount of points, as you can see here, and fill the gaps with more points with a different seed. All the mixture of these different scatters will create a very dense surface. This surface is going to be then plugged into a BDB from particles. The BDB from particles is going to grab all of our points and turn it into a surface. These are the settings I used to make the most out of it. I then proceeded to convert this into a BDB. If I tried visualizing the car, you will notice that if we put one next, or I do this and then I do this, you will notice that it is not quite so perfect. There is a little bit of space, and you will notice this. So before going there, I decided to just smooth this surface a little bit because some of the edges were really rough. So just wait a moment to make it a little bit better. And we're going to grab the original car and we're going to ray it with minimum distance. So have a comparison between this. Let's see one place which is very noticeable. This, for example, and this one. It shrinks a little bit, but it shrinks sufficiently enough in order for the simulation to work way better. So you can have closer shots. It doesn't look like much, but believe me, I tested a lot and this was a lifesaver. You can even make this even a little bit smaller. It will change just a tiny bit, barely noticeable, and it will do great. There are tons of geometry here that we do not need, so a poly reduce, which I already saved it, will look something like this, which is way better. The settings I used in the poly reduce were keeping 10%, nothing else, and that's the collider. Moving on to the actual cloth preparation before the simming, we need to grab our patch right here, which we made it here, and we're going to blast the top. You remember we had the geometry with a group on which was selected on top. Well, this is the blast that grabs the patch top group. And we're going to say, hey, this is the start, because our point already has on points end. And we're going to say, hey, this is the start and this is the end. So we're going to mix between both of them. And we're going to connect based on these settings to the point. You will notice we will have 25 polygons because there are 25 points and all of these points will merge to this one. This is perfect. We don't need anything else. And we can say, hey, this group is going to be called ropes. We're going to resample this so we get more points in between. Otherwise, it's going to be just a singular line. Then we're going to move into a for each. Why we want a for each primitive? This is called for each primitive. Because we want to loop for each line. We want to detect when is this point and when is this point. So there is a little snippet which is called, well, I have it saved as first last point group, which basically says, hey, your endpoints are called endpoints -1 because it's always offset by 1. And if the point number is equal to 0, then the start is 1. And if the point number is equal to the end point, you are the end. So now we have the end and the beginning, or the beginning and the end, it depends on how it reads. Then we're going to fuse it. Why are we going to fuse it? Because look at this. We have 1015 points, and now we have 991 points. Why? Because this last point was overlapping. We had a lot of points, and we want 1 point with one group and all these lines converging. Then we're going to use a group. We are going to grab the same points. We're going to grab a sphere, which is basically very small, and we're going to group by bounding box, and this is going to be called pin. This is basically so we can control it with later on an animation. We're going to grab our patch. We're going to call this cloth, and we're going to merge both of these guys together. You should have something like this, and this is the static patch. This is what you want. Moving on, we're going to grab our patch. We are going to transform this guy. This is going to be an animation. This is going to be dragging the whole lines. So we grab the pin and we just animate it with these pivot translations. So we can have, if we press enter right here, we can have the pivot wherever we want. In this case, it's in the center of the geometry, pretty much. Imagine a bounding box. I decided to have this preset. And then I decided to grab the ropes and separate them a little bit, because otherwise you are going to have interpenetrations with the cloth. This is basically mandatory, so don't forget to do it. And that's our patch, or animated patch, because it is kind of something like this. When we grab the patch, the animated patch, and we grab the collider, we're going to merge both of them together. First of all, we're going to work on our cloth. This is the cloth. So what we are working on is to make the properties of this main patch. So I decided, because you always want to press enter here with no points, you press enter. If you visualize the thickness, you can see that there are some small points here. I'm trying to make this as small as I can in this case, because I want it to be very bendy. You can, of course, this is not mandatory, but you can make it really big. But it is important that it never, ever, ever overlaps with each other. Otherwise, it's going to be a mess. The idea behind this, why it's so small, is because I originally have this patch with this density. I'm going to let it load. And because this is procedural, it's going to work regardless of what I do. So you can see the spheres now make more sense. I'm just going to leave it at 8 as we had before, so it's faster. And I'm not going to change this because I want to let you know that this is only to do a fast test. Then we're going to make the strings. The strings are these ones. I decide to grab the strings. I decide to grab the ropes group. And I decided to use another setting for this. I could grab an unchanged thickness, or I could set it on my own. I decided to go the easy way and just do it unchanged. And let's go back to the cloth. The clothing has a stretch of and a damping of 0.02. This is because we want to avoid all the bounciness, and we enable plasticity so it remains in some places with the shape it has. I would try not to use this. You can test both of things together. I decide to use it. You don't need to use it. And then on the bending, so how much the cloth bends, I have damping of 0.05, because if you don't have the damping ratio, what is going to happen is going to bounce all over again, unless you do some modifications on the Vellum solver. Look at the setting, the stiffness is very low, so it bends a lot, like silk. Moving on to the to the string, we have pretty much the same, but the stiffness is a little bit stronger. It's going to be set to 1, and the mass is going to be very low, so it doesn't drag the cloth down. I just want to pull, but I don't want to drag with the same weight of the cloth, of the string. When we move to the pin, the pin is basically this one. I'm going to calculate these densities and this length, which is pretty much, it doesn't really matter because you're going to just keep the animation and the pin is going to be soft. It's going to be a little bit better. You could use permanent and it would be the same. I decided to use soft so it's not so static and it can move a little bit longer here. And the stiffness is going to be set to 0.1. The glue, this is the most important part, is basically a way to grab each point and connect it to the closer point group or cloth point group, which we created, if I'm not mistaken, somewhere around here. This is point group. Remember to use point group, otherwise it's not going to work as you expect. So we have these densities with this length or with this thickness, so it's not going to interpret on its own. We need this spacing, as you can see. We are not going to visualize a line here, but it's going to work. Well, then we're going to go to glue search. This is max distance, which is more than enough because this is less than 0.2. This is max search points, but we only want constraints per point 2. Basically, A and B, nothing else. We leave everything as it is, and we can move forwards to the simulation. I decided to have a wind drag and a velocity damping, so it's not so bouncy. And pretty much these are the solutions. More subtle, so it's not so glitchy. More constraint iteration, so it's more precise. More smoothing iteration, so it's more smooth because I want a smooth solution. More collision passive because our collider is very complicated. We need to polish this a lot, and let's polish it even more. These are the post-collision passes, and these are the polished passes on their own with the collisions. It's in this particular case mandatory. In perhaps in your situation, you're not going to need that much of a setting. And we'll let it run, and you will notice it's starting to work. If you want to have features, you need to have a bigger resolution. So this setup might take you 1 or 2 hours to solve, depending on your computer. But believe me, at the end of the day, it is worth it, because it's very hard to have a convincing effect without solving it. If it's a static mesh, you can always have the basic mesh like this and then post-produce it in ZBrush. And as you can tell, this is starting to pull the sheet, the patch, and the collider works just fine. Of course, you can always even lower the resolution of your mesh a lot more. I'm going to show you the problem with this collider, which is the following. The problem is that even though this is very nice, it is double-sided. And you perhaps do not want to have this. You want to work a little bit more. In my case, I decided to go this because it just works. I don't mind waiting a little bit more, but for your solutions, you might want to spend a little bit more time on your collider. So once we have this, I decided I'm going to use the high resolution cloth, which is the same, but with more resolution. I decided to use a Vellum post process. The Vellum post process, which I'm going to use right now, this low resolution, just so we can see, is going to basically smooth it out. Look how much nicer this is, and it's going to remove some certain collisions. So it's mandatory that we have all these saved. This is a Vellum IO. These are the settings. These are the settings I decided to save from the frame range. I saved it here on DoraHib/cache, and here there's nothing else. You could visualize some things if you want to show how it's stretching. I just was messing around. We have two things. First of all, we do have the trail node. I mean, we do have the velocity, but I decided to use the trail. There's not a real reason why in this case, if it's not going to be animated or it's not going to be time warped, we need the trail. So I'm going to turn this off. We have a color because perhaps you want a color, and I have the normals on vertex for this edge. As you can see, it's going to make a better edge. That's a normal way to do it. But I also decided, if you follow one of my tutorials, you will see, I decided to use this little thing that basically, because I had some little shakiness here and there with the clothing that I wanted to get rid of. What was the way to get rid of is with a flange shape, because you grab a really nice shape that you want, which is, for example, this one. I like how it looks here, and it's not going to move, and I transition from one frame to another. So I have this shape which is animated and whatever, and it's bouncy. If I show you, this is very bouncy, a little bit bouncy. I don't want to have this movement, this dragging movement. So I decided to make a blend shape from point A to point B, and it stopped. But the velocities are still here. So in this case, I decided to add a trail node. And this is a better retime node. What does the better retime node do? Basically, I have the animation, and I decided to make it slow from point A to point B. This is the slow part. As you can see, it's also very slow on my machine because it's a lot of polygons. And then it's going to go back into a very slow motion thing. And if we go here, it's going to go fast again and slow again. Right here, I believe. Yes, right here is very slow. But it's a very nice node. We have a tutorial for this. The link is going to be down in the description, so please try to look at it. Or you can do it with a custom time blend node. I also decided to use a time shift here. I also decided to use a time shift here, so we started with this fall down instead of back up. And I also decided to use my battery time node, which you can get on the Patreon, or you can build it on your own. I decided to use this frame range. Remember, again, this node is very useful and you will love it because you can use it for RBD, you can use it for Vellum, you can use it for grain simulations, you can use it for anything. And it works, except with volumes. Of course, volumes is another topic. And since the trails, since the velocity are changing due to this better time node, we are going to use this trail. And this trail is going to recompute the velocities based on these two guys. And that's pretty much it. If we turn everything on, it's going to take a little bit more because, of course, the Vellum process is very taxing on the computer. So yeah, this is how it looks at the end. I believe this is a very nice solution for what your sims need. As you can see, it collides pretty good with the geometry, so you can do some kind of close-ups. Of course, if you want to have a really close-up, you are not going to be needing to use a whole simulation like this. You probably are just going to use a patch for this, otherwise you are going to waste a lot of resources. That's about it. Hi guys, I hope that you enjoyed the tutorial, so please leave a comment, ask anything, join our Discord, and if you want a file you can also go into my Patreon and download it from there. Anyways, I hope that you really enjoyed the tutorial and we will stay together to the next one. See ya!